https repo.doctorbirch.com, and it should be https, and it should be repo, repo, like so. So this is all my code, a lot of different things. Sociopath, that is this program, a program which you can download and upload files to a server, and you can also live edit stuff with your favorite editors such as VS Code or Brackets. And this is coded at 100% JavaScript. It's 12,000 lines of JavaScript, my biggest coding project ever, actually. And here you can download one thing at the moment, that is my needle, which I will talk about today. So that's also why I wanted to show you this. So download that zip file, that is the easiest way. You can also do like, let's say we go into a temporary directory and we create a directory called needle. And if you have the Node.js installed, then you can do this. Otherwise, download from the repo or install Node.js. But you can do npm install needle threads, like that. And then you go into the node modules and the needle threads, and here we are. So this is the library. Basically it's just two files. It's the H file and the C file. Then there is an example. We're going to do something similar to this today. And on Sunday we're going to do something way cooler with this library. And then there's a make file as well. That is quite basic stuff for a library. We just compile it the same we did our arc4 library to an SO file, and then we copy it to the right location. If I have the time left, I will show you how this library works under the hood, but I believe that will be the next episode instead, because what we're going to do today, that is we're going to create a program which uses threads, and it uses concurrency between different CPU processor cores. So we'll basically run 4 tasks exactly the same. And I'm going to show you how easy it is to work with this in C with my library, because the alternative that everyone has been using for years and years, that is pthreads, the POSIX threads. It is also very good library, a little bloated perhaps, a lot of features I have never used, and my library does only contain the stuff that you need basically. Okay then, let's start coding. First of all, I need to install the library, so let's go back to that directory where I were. So where was it? Needle, and then the node modules and needle threads. So it's a two-way process. First you need to compile everything by running make, and then if it succeeds, it says to install the library type sudo make install, And it needs sudo because if you look at the beginning of the make file and check out this line, libdir equals and this stuff. So if we just paste this in, just to show what's going on, and then we do the libdir. So let's just echo this stuff to the screen. And then you see the libraries will be installed in this directory. So in 64-bit Linux systems, the directory usually looks something like that. In case this fails, if you install this as root and it still fails to copy it to correct place, then the libraries are in a different directory on your machine. So you can basically do ldd bin ls, and you should be a little bit wiser. If you look, for example, after libc, it's in lib x86-64 Linux GNU. So this is what you should put. If we copy this part, let's do a make clean first. So we start from the beginning. And let's go into this make file. And the libdir, let's just delete all of this, all the way to the equal sign. And then lib x86-64 Linux GNU. So that's how you can do it manually. And then it's just do make and sudo make install. And there we are. Now we can compile stuff using this library. So let's go back into my home directory somewhere and let's create some example project. Let's just call it mkdir needle my example, like this. And let's set my home to this stuff. And it could be a good idea to have, let's see, yes, let's have the manual up as well. And if we go to npm.js.org and we search for needle threads, and you need to type it exactly correct or it won't show up. This website is a little bit discriminatory. Oh, so 678 weekly downloads, and it's only been a week, so quite okay. And as you can see, it supports the local variables as usual, but also global variables, which are shared by the different threads. These are the so-called needles. And they have automatic mutex protection. I'm going to be talking a little bit more about that when we get to that point. Basically, it's about not reading and writing to the same variable at the same time. And that's always been a big trouble when creating concurrent programs. And it has a multi-CPU core support. So the default is if you use the function spawn multiple to start the threads, then it will count your CPU cores. So let's say you have 4 of them, then it will create 4 different cores automatically. And you just pass it a function, which it will use as its own main function. But you can also use the spawn single, and then you have the power to create as many or as few threads as you want. One thing to remember though, when you use the spawn single command, then you have to do the await needles function. You need to call that when you are done spawning the threads. Because if you don't, then it will create zombie processes and stuff like that. So be careful about that. When you run the standard command, the spawn multiple, then it takes care of all that automatically. So you don't have to worry. I install my make and sudo make install, and here is the whole API. I'm not going to go through it right now. But here is an example program, and I'm not gonna copy paste all that stuff, but these 3 lines I will copy paste. Alright, so how are we gonna do this? Let's go into sociopath and the temp directory, and what did you call it? Needle my example. Let's open this in the editor, and let's go into the directory, select something and deselect, and then minimize, because it works much better when you do it like that. If you wonder why, I'm gonna discuss that at a later time. By the way, before I forget, I of course want to say thank you to my members, Arnab, Henry, Dev, Ananya, and I have already said plenty of time to Jagmer, so I hope you all feel welcome. You are helping me create good content every 4 days, because I need subscribers, I need members, I need tier 1 members, I need a couple of everything to be able to work with this 100%, because this is a very difficult job if you have another job to focus on as well. And I will give you all my focus so I can be creative and do exciting projects. So let's see. These guys are members, and Arnab, my dear friend, he is a member, and I just promoted him from a regular moderator to a chief of moderators, and we'll discuss on Sunday what that means as well. And this is how long they've been members. This is how long it's to the next level up, because if you are a paying member, you do an automatic level up once a year, is it? And then you get a new icon instead of this star, and you get a new title, which is hacker level 1 for most, and that actually means something, and I'm going to talk a little bit more about that when we are closing in on the next summer. And then we're not going to talk about that column right now. Alright, so let's code this thing. It's very easy actually. It's usually not easy to code concurrent things, but I think every single one of you will be able to get this stuff to work. So what I'm about to do is I will just create one file, I think. Let's call it needles.c, and I hope it's big enough for you. Should be, I guess. And we're going to create a program where the main program will create a variable, and then it will spawn 10 threads, and each and every one of these threads will have access to that shared variable. So what they're going to do, they're going to it's going to be 0 from the start, and every thread is going to read the current value, increase it by 1, and write the current value back. So it starts at 0, and when the 10 threads are done and has exited, the main program will check what the value is, and hopefully it'll be 10. The only way it won't be 10 is if one of the threads crashes, which they will not do. And the second possible reason is that the concurrency doesn't work properly. So they try to read and write to the same variable at the same time, which will basically corrupt the data, and then it can get all kinds of different results, but probably something like 8 or 9. But that won't happen either, because if you do this correctly, as I will, then it will work every time. It doesn't matter if you have 1 or 10 or 100 or 1,000 threads. Alright, and the machine I'm working on is this Linux machine called Planet. And if we do cat proc CPU info, and we'll pipe it to more, then we can see that it's a quite good machine. It's an Intel 2600 megahertz and Xeon. And here is the first processor, and now we missed the second, but here is the third and fourth. So this virtual machine, anyway, CodePlanet server, has 4 CPU cores, which we will use in our first example. So okay, let's copy this code again. Forgot to paste it in. So let's start, by the way, by including the needle.h. Perhaps I can lower one step. I think this should be okay, right? And then I will just paste in those external variables. Not much to care about. I'm also going to create just 2 different function declarations. So we're going to have a main function, but we're not going to have any arguments. And we will also have some kind of main function for the threads. So let's call this void thread main. And let's see, thread main. We will have one argument right here. It's an int 16, and it's called nid for needle ID. We don't need that, by the way. So every needle has a unique nid, which is a non-zero integer. Okay, so what are we going to do in this program? Inside of main, the first thing I want to do is initialize the library. And we do that by creating a memory segment, a common heap. And this heap will be the shared memory segment where we will save all the data in the variables which will be shared by the threads. So it's quite easy to run this stuff. All we do is we call the minute, and it takes in one argument, and that is a number like 2000, and that is how many bytes of data to allocate. And why it's called init? That's basically because this is the initialization function, right? Init. And all the functions have an n as a prefix, n for needle. And that is basically because if in case you want to use this in your current code without having to replace a lot of stuff. Okay, but I want to have 20,000, so I can write it like this. But a better way is using a macro. So there is a macro called kilobyte, small letters, and you can just say I want 20 kilobyte. Like so. And you can always do megabyte as well. And now everything is initialized, so we can continue on by creating a variable. We use let in order to do that, and then we just give it a name, and it can be any alphanumeric characters like letters, small and big, and numbers. You can use underscore, and you can even use a prime symbol. But in this case, let's make it easy for us, and let's just call it x. Okay, so now we have a shared variable. Now we want to create our threads. So we can give a message first, launching threads. Something like that. And what we do then is I'm going to test the first. There are two functions, as I said. I'm going to use the most easy one first. So let's see. We will call spawn single, and no, it should be spawn multiple. We're going to take all at the same time. So spawn multiple, and it takes only one argument, and that is the main function, the threads main function. So basically we just put an ampersand because we want to send the reference address, and then the name of the function, and I think we called it needle main, like so. And we don't have to wait for these threads. So what this command does is it starts all the different threads. They run this function, and all other functions during their lifetime. When all the different threads has died, then the main program goes to the next line of code. So basically we can put a printf here saying something like all threads are dead. And I forgot, we do want to initialize the variable. We have created it with let, but let's also set it to 0. So that's easily done. You do it the same way in the main program as you do it in the what it's called, in the threads, in the needles. You just use the command put, which takes 2 arguments. The first is the name of the variable, which is x in our case, and then the value 0. And you need to cast this value, and this should be an unsigned long integer, because all variables are 64-bit in size, and that's basically because with 64 bits you can do pretty much everything. You can use it as a pointer, because all memory addresses are 64-bit. So you can, it does only support one size of variables, but that ought to be enough for anyone. If you need 128 bytes, for example, for like a string or anything, just use 2 different variables. Okay, so now we have set this one to 0. Let's just check if everything works this far. So let's comment this out for the moment, and this doesn't work anymore. This does. Okay, so let's just do return 0, so we don't start troubleshooting a lot of thread stuff when we have errors inside of the main function. Let's do like this, and we will just save it. And let's go in here, and where are we? My example. And it's quite easy to compile. You just do gcc needle c -o needle, and then you add -l, and then a library needle, like this. It compiled fine, and I think it will run just as fine. Yeah, it just prints the messages. Nothing else has been going on at this point. So let's add the concurrent stuff. Where were we? It should be inside of this one. Alright, so let's put back spawn multiple, and then we just need to create this needle main function. And it's a void needle main, and it takes an int 16, which we call nid. So the nid is the process ID basically, but the thread's own ID. It's not the same as the process ID. Alright, so let's see. We need some intermediate variable. I think it will be easier to understand them. So let's do an unsigned long int n, and we set n equal to get and the name of the variable, which is x, and we need to cast, as we did before, to an unsigned long integer, like so. So now the thread has read the value of this variable, and it should be 0. So then we increase the n to 1, and now we want to update the value of the variable. So we will just do put, and the variable name is x, and the value is n. And as usual, we need to cast, and we don't need to do anything with the variable name. That's already taken care of. But the value that we want to change, we need to first do, let's see if I remember this correctly, put this to that. Is it enough with unsigned long int? Let's try this first. Perhaps I need to change it. And then let's just do something like, no prints, by the way. Never mind that. And then we do return, because the exit call will happen automatically. Okay, I think that should be enough in case I haven't forgotten anything. So let's compile again. No errors, warnings. And if I have coded this correctly, we will spawn 4 threads on 4 different CPU cores, and we will add to that variable. By the way, I never printed the result from it, right? That is quite important, right? So all threads are dead. Printf value of x is, and we take a new line like this, and then we just do printf %d, and we'll do a new line here, and we want to do get x, but this time we need to cast it a little bit. First of all, it needs to be an unsigned long int, and then we need to have this in a parenthesis of its own, and then we want to have it as an unsigned integer. This looks about right, I think. And that is basically just so we can print it as a regular int and don't have to think about LU and stuff. Like so. Let's recompile this real quick. Boom. And hopefully it will work. Okay, what is happening here? Launching threads. We start it on different CPU cores, and we see the NIDs to the left. All threads are dead. Value of x is 4. And it doesn't matter how many times we do this. It's always the same, because they are locking the variable when they are reading and writing to it. So it's not even possible for 2 threads to sabotage for each other. Don't forget to show up on Sunday. Let's all celebrate together. Maybe there will be some kind of prizes. Maybe some of you will give me something because of the celebration of 10,000 months. I don't know. But what was I thinking about? Yeah, I haven't decided the time 100% yet. I think it will be at 11 Central European Summer Time on Sunday. But I will confirm it like tomorrow or something like that. And the topic will be cybersecurity, I think. And not just any cybersecurity, it will be developing cybersecurity tools in C. That is my topic suggestion. And some of you wanted to learn shell scripting, and I think I can include that in this lecture as well. Okay, that's basically it. Like and subscribe if you wish to get more of this stuff. And next time I will show you the library and the more advanced features of it. Thank you for watching, and thanks for today.